Okay. Our webinar today is hazard communication. I've heard it over the years. People say this is hazardous communication. The only hazardous communication I can think of is maybe you're swinging your hands around too much and you poke somebody in the eye. This is hazard communication. How do we convey what hazard a chemical has? How do we share this information with our coworkers? And that's really what it's about. It's an OSHA standard and all of that, but at the end of the day, it comes down to your safety. When I'm working around chemicals, how do I keep myself safe? And so our goals today are to learn the basics of chemical identification. You ask yourself, well, chemicals, I'm not out there working with sulfuric acid. I'm not working with something really toxic. Well, the truth is chemicals are all around us, and each of us work with those on a regular basis. And so we all have an obligation to understand how to identify the hazards of these chemicals and how to protect ourselves. So in this, we'll talk about a system to identify chemicals and their hazards. We'll talk about product labels, and you say, oh, that's no big deal. Well, it's changed a lot within the last few years. And luckily for us, it's gotten a lot better than it was before. But there's a system to that. And so we'll go through that. We'll talk about where to go for information, how to find information about what we're working with, physical and health hazards, and we'll also talk about the OSHA standard just a little bit because that is an important consideration. The last couple of months we've presented some webinars on OSHA visits, and from what I understand, OSHA is actively out visiting several of our members already, and they're going to continue to visit local governments around the state as time goes on. So get ready for their visit. And we'll help you. It will help you prepare for that. This is the most common OSHA cited standard almost every year, and so it's definitely one you want to make sure it is in good condition. That we've done the training, that we've got a good labeling system, and we have all of our SDS sheets, and we'll hit all that stuff right away. I did want to point out to start with, though, the employer responsibility on this training. We're providing the basics of hazard communication training, and then your employer has the responsibility to provide the additional information specific to your location. So what do I mean by that? Well, I can't train you on the specific chemicals that you work with because I'm not there. I can't train you on the system that you have for labeling. I can't train you on a lot of the specifics that go into your workplace. And so with that, I have to lean on the employer. At the end of the day, under the OSHA standard, your employer is the one that has that responsibility to provide the training to start with. We're here to help out and give the basics, and then that detail needs to be done by the employer. So just remember that, and if you haven't had some specific training, let's figure out a time to do that and work with your employer to get that. Like I said, chemicals are all around you. I can guarantee you there's probably something under your kitchen sink or your bathroom in your bathroom cupboard that could kill you. There's definitely something in your garage that could burn your house down or cause another serious problem to happen. And so we need to be aware that chemicals are all around us. We all use chemicals. It's not just that sulfuric acid or chlorine gas that we may think of when we think of chemicals. And so each of us have a responsibility to handle our own safety, to know what we're dealing with, know the hazards, and know how to protect ourselves. We're all at risk, but we all have the ability to protect ourselves from chemicals. All right, let's go back in history quite a while. 1994, prior to 1994, your employer didn't have any responsibility to tell you what chemicals you were working with. So that really stinky stuff or that nasty stuff that gave you a headache or made your head spin when you used it, your employer could just say, get to work. Go out there and do what I tell you to do. Well, in 1994, that all changed. In 1994, OSHA promulgated the Hazard Communication Standard, and it was known as the Employee Right to Know Act. And what it required employers to do was provide employees with information on the chemicals that they work with, to tell them what's in a container, label it appropriately, have a material safety data sheet or MSDS for each of those, have a list of the chemicals in the workplace, and train employees on those things and the hazards associated with those chemicals. This was a revolution. And like I said, since this time, this has been the #1 or almost the #1 most common OSHA cited standard every year. It's one that is hard to comply with all the time, and just a few years ago we changed the standard and made it much more complex. So I would highly encourage you today to review your standard, review your SDS sheets, review your list of hazardous chemicals in the workplace, and see how you're doing. See if you've got training documented. All of these things to, one, be compliant with the OSHA standard, but two, for the overall safety of our workplace. From this standard, it basically said if you have a hazardous chemical in the workplace, 1% or 0.1%, if it's a carcinogen at that small of a concentration, you need to have a material safety data sheet, MSDS, for that material. It needs to be on a list of chemicals in the workplace, and you need to train employees on it and provide a labeling system. So if I take a material from a bulk container and put it into a spray bottle, for example, I have a label on it that all the employees in the work area can understand what it is and what the level of hazard is. This applies to a lot of chemicals that are out there, things that you might not even think of, cleaning chemicals that the janitorial staff might use, disinfectants, solvents, standard things that we think of, acids, but oils and lubricants and fuels, all of those things fall into this standard. So just a few years ago, though, OSHA entered into an agreement, or our country entered into an agreement with the United Nations to adopt the globally harmonized system for labeling and identifying chemicals. What this did is it harmonized the worldwide standard, where we had many different standards based on different countries. So one chemical might have 10 different MSDS sheets. It might have different labeling requirements from one country to another. Well, that caused a lot of problems in the chemical world, and it also presented some hazards to people working with those chemicals. So just a few years ago, OSHA came out and said, we are going to adopt the globally harmonized system which standardizes how chemicals are labeled, standardizes data sheets, safety data sheets, changes the name from material safety data sheet to safety data sheet, and we're going to do that so the whole world can get on the same boat. I just see Nate said they lost audio. Doug and Brent, are we still good? Can you still hear me? That's a Nate issue.
Still hear you fine.
Okay, good. Maybe would you send Nate just a note to update or to check his volume controls? He may have to log back in. So this system is important. It's one that worldwide we can standardize how this chemical flows from one place to another and keep it safe. So it's a good deal. This right to know that we talked about, I have a right to know what chemicals I'm working with, has now become a right to understand. I need to understand what the material, or not only what the material is, but what does it mean to me? What is the hazard to me, and how do I protect myself? All right, I'm going to skip through just a couple of these. So an employer, like we said, has a requirement to have a written hazard communication program, a list of chemicals, train the employees on the hazards of those chemicals and where to get the information, whether it be through an SDS sheet or other form of information. They need to have a labeling system that everybody understands. So if we're using a secondary container, what does that label look like? Does everybody know what it is, and does it tell me what the chemical is and what the degree of hazard is for me? We also need to provide safety data sheets for every chemical in the workplace. Now, can that be a hard copy? Yes. Can it be electronic? The answer is yes, but it needs to be able to be accessed by all employees when they're working with that chemical. So if you have a computer system that's set up in the workplace and so they can easily access that, then that's okay. If not, if they have to go through a lot of effort to get to that SDS sheet online or over the computer, then that probably wouldn't meet the standards. So I always like to have a binder, even though they're a pain to keep up to date. I like to have a binder available so everybody can get a hold of those SDS sheets when they need them. Okay. All right. We'll jump just a couple of things here. The manufacturer of chemicals has the burden of classifying and labeling the chemicals to start with. They've gone through a lot of gyrations in the last few years to update to the new standard for labeling, but it's their job to give us the information, and that's a good thing. So let's talk about labels just briefly here. And you say, it's a chemical label. We know what that is. Oh, good, Nate got it back. Sorry about any difficulties there. I think everybody else is okay. These labels have been standardized across the globe. So you buy a chemical in Timbuktu or Manhattan, it will have a standardized label. That's good. That's a good thing for us. So let's talk about these labels, how they're standardized. We start at the top with the most important information. What is this stuff? So there's a product identifier. So if you look on this label, it says HS85. That's the product name, top of the label. Okay. After that, what is it? How bad is it? We have a signal word. Just one of two words, danger or warning. Which one of those words is the worst? And it really is danger. So depending on what the signal word is that's being used, it'll tell us right out of the chute, oh, this is bad. It says danger on it. I have to be more on guard because of that signal word. What is it? How bad is it? And then the next part of the label is what can it do? What can it do to me? A hazard statement. So things like may cause fire, explosion, strong oxidizer, causes severe skin burns and eye damage. What is it? How bad is it? And what's it going to do to me? So what would be the next thing that we would want? How do I make sure this stuff doesn't hurt me? So a precautionary statement. What do I have to do to make sure this doesn't hurt me? Keep the container tightly closed. Store in a cool, well-ventilated space. Use only non-sparking tools. Pretty simple things, but in an appropriate order. What is it? How bad is it? What's it going to do to me? And what do I have to do to prevent it from doing that to me? It's a great organizational structure for a label, and it's in the same order on every one of these now, so it's easy to find. All right. You might have seen on that label there were a bunch of pictograms. What do these pictograms mean? Well, the idea behind a pictogram is we want to be able to give out quick information to an employee that can be easily understood. Maybe you don't read really well. Maybe it's across the room. I can see this pictogram, and what does it tell me? What's the message that this pictogram is trying to convey? This is actually one of the areas where I have a little bit of a beef with the globally harmonized or GHS system. Is some of these pictograms maybe don't share the complete message that I think would be better. So your guess on this pictogram, this is for a health hazard. And it conveys a wide variety of different health hazards that go along. So this pictogram might be on something that's a carcinogen, a reproductive toxin, a respiratory sensitizer, a wide variety of different health effects that can happen to me. How about this one? Well, this one's pretty simple. We've all seen this flame picture. And so this conveys a number of those hazards going along with flammability. This one here is probably familiar to a lot of us as well. We've seen this on our car battery or other products, maybe oven cleaner, and it lets us know that, hey, if I spill this stuff on my hand, it's going to take a chunk out of my skin. This stuff might affect my eyes or something else like that. So it's a corrosive. Here's another one. Well, this looks pretty familiar. It looks pretty similar to that other one we looked at just a couple ago, but it has a circle underneath these flames. What does that mean? Well, it means it's an oxidizer. This stuff doesn't actually burn, but it has the potential to help other things burn stronger or more vigorously than they would have otherwise. So things like oxygen or chlorine gas are oxidizers and can fill this role. Okay? Gases under pressure. This pictogram lets us know that, ooh, there's a lot of pressure in here. It might be toxic. It might be flammable. If I have a compressed gas cylinder, it has some danger to it. So I'm going to work carefully with that. Exploding bomb. We pretty much understand what that means. And how about smiley face guy, the skull and crossbones? That tells us that this is toxic or might be fatal to me if I touch it or eat it or breathe it. This is one that, as a child out working on the farm, I remember looking at pesticides and seed that had been treated, and seeing Mr. Smiley Face skull and crossbones guy and thinking, ooh, I better be careful with that stuff because that could be hazardous to my health. Exclamation point. This is another of those pictograms that I don't really like much. It's kind of a catch-all, and they throw a lot of things in there, anything from acute toxicity to hazardous to the ozone layer. So I have a little beef with this. I think we could probably be a little more descriptive, but this is the system that we've got, and it'll probably get better over time. If nothing else, we'll become more familiar with it. So your SDS sheets, your safety data sheets, have replaced the MSDSs, material safety data sheets that we used to use, and you should have updated all of those in your binders for those lists. The great thing about an SDS sheet is it's a standardized format. So we have 16 standardized sections, and if you want to know what the material is, you go to section 1. It'll identify the material and tell us who the manufacturer is. Some of that most basic information that we might need about the material is in section 1. If you spill the stuff on you and you want to know what the first aid is for a splash of this material, go to section 4, and it'll tell us exactly what to do there. If it's on fire, go to section 5, and so on and so forth. And this is the same for all chemicals. It's a good deal. We've been trying to get this for a long time. There are a couple of sections that are environmental sections that are not enforced under OSHA, but they could be under other regulations. So if you get these in, don't just throw it away. If you get them in with a new shipment, don't just throw them away. Make sure that we've updated the SDS sheets, because the manufacturer only, or supplier only, has the requirement to send them to you once. After that, you've got to go after them to request the SDS sheets. The first shipment, they're required to send that. Beyond that, you've got to chase them down. Okay. Everybody needs to be trained on safety data sheets. So my challenge to you today is to go out and find your SDS sheets, find your binder, pull it out, and verify that you've updated those to the safety data sheet and that they're there. And familiarize yourself with the different sections. So if you're ever concerned about a chemical you're working with, or maybe you have a current concern, you can look those up and get the information that you need. Okay. Inside those SDS sheets, they are going to call out hazard classifications. And like I said, the manufacturer has the responsibility to classify these materials, but we have the responsibility to understand what those hazards mean to us. So there's 16 physical hazards, 10 health hazards, and a couple of environmental hazards that are not required under OSHA, but still may be required under some other standards. So there is a chart for physical hazards and a chart for health hazards. And the standard convention of this is when we divide these hazards up into categories, and it could be anything from 1 category all the way up to like 7 categories. The lower the number or the lower the letter the greater the hazard. This is the standard convention. It kind of goes against some of the old systems that we've seen, but that's the goal that has gone forward in the GHS system, is let's standardize this. So if I have a low number or low letter hazard, it's going to be the most dangerous. Okay. Let's talk about and some of you might be saying, hey, what about this? What about this NFPA thing? I remember this diamond. A 4 is bad on that system. Well, that is true. And unfortunately, we've got systems that kind of counteract each other. NFPA hasn't changed this yet. Hopefully they will. But if they don't, we just need to be aware that in this system, a 4 is the worst. But in everything else, it's going to be that lower number. It doesn't hold true in every one of those classifications, but it's pretty close. Okay. All right. So let's just hit these hazards really quickly. Explosives. That's not too hard to figure out what an explosive is. This is something that if it's detonated, it can cause damage to me or property, buildings, all of those things. Lower the number, the greater the hazard. So division 1.1 hazard, that's actually a DOT division that we just used because it was already in existence. Those are mass explosion hazards. They can throw things over a mile. Flammable gases. These are things like acetylene you use out in the shop that can catch on fire and cause damage. Or maybe it's that methane out in the sewer system that can blow up. Flammable aerosols. These are materials where we have a liquid and we put it into a very fine mist, and if it happens to be flammable, they can be extremely dangerous. Those aerosol cans. That's why we ask you to place all of those in a flammable storage cabinet, or at minimum in a caged area to keep those things from becoming rockets and burning your building down. These have some specific risks that are hazardous to us. We talked about oxidizers. These are gases like oxygen, chlorine, nitrous oxide that can cause other materials to burn vigorously. So that oxygen that you're using in your cutting torch, if you allow that oxygen to permeate your clothing and then you strike an arc, that spark can cause your clothing to just burst into flames because it makes stuff burn a lot hotter than it normally would, or make stuff burn that wouldn't normally burn. So something as simple as oxygen that we use, when we concentrate it, it can be very dangerous to us. You can see it just barely smolders, but when they put it in a high oxygen environment, it actually bursts into flames. Gases under pressure, we talked about that. Many hazards from these, from toxics to high pressure to things get really cold when they go from high pressure to low pressure. There are various different categories of gases under pressure. It could be a liquid like propane or gas chlorine inside of that cylinder. It could be a straight up gas like oxygen or nitrogen. Okay. And these materials have, like I said, many hazards. These guys put some gas inside of a car and then ignited it, and unfortunately got some burns out of that. Flammable liquids, things like gasoline, things that we maybe sometimes don't think about. Gasoline, paint thinner, or other materials, alcohol, that will ignite when exposed to a flame. Flammable solids, these would be things like fire starters, magnesium fire starters that we use when you have poor conditions to light a fire. You light that stuff up, and it'll burn at about 5,000 degrees and will readily light a fire. Here's a magnesium fire right here. What some people don't know is if you get this stuff on fire and you put water on it, it'll explode just like that. Self-reactive substances. These are things that react together and with itself, like a peroxide, organic peroxides. Most of you probably don't use these, but if I let these go out of temperature, they can actually spontaneously combust and cause some crazy weird fires and all kinds of stuff. Pyrophorics, these are materials that if they're exposed to air, I open up the bottle and allow it to be exposed to air for as little as 5 minutes, they can spontaneously combust. So if it says pyrophoric, we handle those in a very different way than we would just a regular flammable. Self-heating substances. This could be something like a hand warmer, where we've just taken iron and ground it up into a really small powder and put it into this sealed container. When I open that container, I give that hand warmer a shake, and what that does is allows the oxygen to get around those small particles of iron and start to rust. Well, that rusting happens. It oxidizes quicker than it would if it's your old Chevy sitting out in the parking lot rusting away. This happens fast, and it gets hot, and that's how we heat our hands up, with those hand warmers. There are certain chemicals like sodium metal where if we put water on this material, it will release hydrogen gas and cause some real flammability problems, cause it to explode. Here's an example of one of these gases, and what happens when you put water on it. Wow. Yeah, putting the fire hose to use would not be a good idea with that material. Oxidizing liquids and solids, like we said, oxidizers make things burn that wouldn't normally. You've got nitric acid and some other things like that. Other oxidizers, hydrogen peroxide could fall into that category. Organic peroxides are nasty because they're both an oxidizer and a fuel at the same time. Corrosives, acids and bases, and these can be inside of our car battery. It can be inside of oven cleaner, and these are nasty things that'll take a chunk out of your skin or cause eye damage. Well, let's talk about the health hazards. We ripped through these other ones. How do I tell how dangerous a chemical is, how toxic a chemical is, as compared to another one? Well, we have a good number that we use to compare those. It's called the LD50 or the LC50. That's the lethal dose 50% or the lethal concentration 50%. And you can go on your SDS sheet and look at these. We can compare, well, and let me talk about what this is. They do a test on cute little lab animals. Sorry. They take 100 of these cute little lab animals and they feed them this chemical until half of them die. And then that becomes our LD50. If it's a gas that we're dealing with, they turn the gas concentration up until half of those animals die, and that's the LC50. So I can take, maybe I have a responsibility to spray the weeds around our buildings, and so I use Roundup or another herbicide. How nasty is that stuff compared to sulfuric acid or compared to the chemicals that I use to clean the sink? Well, you can go to your SDS sheet and compare those LD50 values. Depending on what we get out of those, we'll have a category of a toxin. So if it's a category 1 toxin, I would recommend you get a different job, because those are really, really nasty things. And even at really small concentrations of exposure, it's going to kill you. So category 1 toxins, I'd stay away from those things. But it allows us to compare, what am I working with? Is this stuff really toxic? Am I just nervous? Skin corrosion, skin irritants, so pH extreme, something that causes our skin to react. And along with that, eye effects. We've all got shampoo in our eyes before, and it burns and it stings, and we wash it out, and we might have red eyes for an hour or so, but it doesn't produce any permanent effects. And so if you see something, a chemical on the SDS sheet says this has eye effects, permanent eye effects, we really need to be careful with that and use the proper personal protective equipment and proper procedures to ensure that this doesn't get anywhere near our eyes. All right, sensitizers. This is a material that can cause, it's similar to an allergic reaction. And could cause anaphylaxis or anaphylactic shock, where your throat will close off, and if you don't get medical help, you can tip over and die. You just won't be able to breathe. So chemicals that fall into this category are things like a 2-part urethane paint. maybe the two-part foam in insulation or other material where we're putting foam in to pack around a product as we send it out. The one material in that is called MDI, or methylene bisphenol diisocyanate, and it has the potential to be really nasty to us and cause these sensitization reactions. So if you're working with something like that, feel free to give me a call and let's talk through how we get systems in place to prevent these types of exposures and reactions. Mutagen changes our DNA. Along with that is, here's some mutations I found out along the shore of the Great Salt Lake a while back. Along with that goes carcinogens. A carcinogen has the potential to cause cancer. Doesn't mean it will. Doesn't mean a single exposure is going to cause that. There are different levels. If you look at that chart, of course, the lower the number, the greater the hazard with a carcinogen. Some are just suspected. Do we want to minimize our exposure to suspected carcinogens? Absolutely. If it has a potential to cause cancer, minimize your exposure to it. That's why we learned what these hazards are. What does it mean to be a reproductive toxin? Well, it means that could affect our ability to have offspring. It could affect unborn children that are developing. It could also have some effects on our children that are already born. We list in here a lactation hazard. What's a lactation hazard? Well, this is a chemical that can pass through a nursing mother to her baby. That's a big deal in anybody's world, and it's something that we should be aware of. If you find yourself in that, nursing a baby or reproductive age, we may want to limit our exposure to those. I'd say anytime we want to do that, but it has more effects when you're young and in childbearing age, and that's both males and females. Target organ toxicity. Some chemicals are specific to a target organ or an organ system. So if we have there are things that are nephrotoxic that affect your kidneys. There are other things that affect your liver. Okay, aspiration. This is a material that if you breathe it in, it's a liquid or a solid. It has a viscosity to the point where it can coat the inside of our lungs and make it so we can't get oxygen across our lungs to our bloodstream, and we simply suffocate from having this. There's a really sad story in Box Elder County where a young child, just a toddler, jostled a table that held paint and paint thinners that a family was using to paint their house. The paint thinner tipped over. It was an open container, and it poured over the child's face. And what do you do if something like that happens? You probably gasp. And the kid, I'm sure probably cried. And he took a big gasp, and he breathed in this paint thinner. It coated the inside of his lungs, and subsequently we had a dead kid. There wasn't anything that the medical professionals could do, and this child died. So this is if we have an aspiration toxin like this, this is one of the big reasons when we do rescue breathing and CPR, we always want to use a barrier mask. Use a mask that has a one-way valve, so we can blow air into that person, but they can't vomit or cough some of this material out that could get into our lungs and cause us to be the next victim. All right, there are other hazards that are out there. Combustible dust. We're using any dust that could potentially burn. This goes anything from grain dust to activated charcoal or other dusts. If it gets up in the air, it can be an explosion. So if you have that, we want to remember that as well in our planning and preparation. So in summary, this is an OSHA standard. Your employer is required to have these things in place, but the reality is, at the end of the day, it's your health, it's your skin. You need to be informed. You need to go and check out that SDS book and see how bad is this stuff I'm working with. You know, it kind of stinks, kind of makes me feel a little loopy after I use this material. What is it? So it's your right and it's your obligation to know what you're dealing with. Like I said, challenge you to go out today, look at your list of chemicals. If there's no list there, you got a lot of work to do to write that up. If there is a list, is it up to date? If you have a ton of chemicals sitting out there, I would say do an inventory. If you don't need the stuff, get rid of it. Trash the stuff in an appropriate way. most of your counties, your landfills will have a household hazardous waste disposal thing. They may allow you to dispose of that there. If not, you may have to dispose of it as a hazardous waste. Some of it may be old paint that's dried up and that can just be disposed of. But take a look at what you've got. If you don't need it, get rid of it. And also control who buys this stuff, so we don't end up having stuff we don't have an SDS sheet for. Update your labeling system. If you don't have one, you go out and find a spray bottle that doesn't have a label on it. Get a label and make sure it's standardized for your system, for your whole organization. Update your SDS sheets. Look in there. If it still says MSDS, then you should go online and find or give a call to your supplier and say, I need SDS sheets for everything that we buy from you, and be specific about what you get. Okay. And then some basic chemical safety. But I had a question come in. Are there templates for a written HAZCOM plan, or is it better to just create one? We have a basic plan, and I'll send that out this afternoon when we send out the notification on the recording when it's available. Hopefully it'll be this afternoon. It might be tomorrow. And I'll send out that basic plan. But please, 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 when you use a boilerplate, make sure that you tailor it to your system. Make sure that you've read it, you understand it, and tailor it to what you do. Basics on chemical safety. There are a lot of standard things, standard chemical safety principles. But number one thing, make sure you're wearing your personal protective equipment. Make sure you understand the chemical and what you should be wearing. It's there. You have the information. That SDS sheet is available. Understand what those risks are, and make sure that you put the controls in place to protect you from that. So, all right. Just looking to see if we have any other questions. Doug, Brent, what did I forget this time? I did the first one in my truck, and so
I think you got it covered well.
All right. I'm not seeing any other questions there. I'm going to wrap it up. Apologize, guys. I went a little bit longer than what we'd allocated on time to start with, but it's just a giant subject. We appreciate all you do out there. We appreciate your attendance to these trainings. If you have questions, feel free to call us. Doug, Brent, and myself are happy to field your questions. We'll be sending out a notice on this recording for this webinar, so you can go back and review it if people missed it, and also send out a boilerplate HAZCOM written plan as well. We're going to turn right around and do the next webinar. Doug's going to be on talking about the Trust Accountability Program for 2018. If you haven't signed up for that, send me an email right now, and I'll get you a link out right away. Okay, thanks, guys. I appreciate everybody. Go out and have a safe day.